this is the second half of section 8.2. In 8.2 part 1, we focused on simplifying rational expressions and multiplying rational expressions. We also talked about domain restrictions. So if you are good at factoring and you are comfortable using the zero product property, then that lesson for multiplying rational expressions wasn't too bad. And if you're good at the multiplying rational expressions and understand the domain restriction, we basically have 2 extra steps when we divide. And other than that, this would be a simple lesson for you to add on to your knowledge. All right, so the first thing you want to remember is that we are not going to divide fractions. We are going to always multiply by the reciprocal. So instead of dividing by a fraction, we're going to multiply by its reciprocal. So we did have a fraction review lesson that's been recorded, which is a really good practice for what we're working on. So we have 1/2 divided by 3/4. We leave the 1/2 alone, and we invert or take the inverse of division, which is multiplication, and we follow that with the reciprocal of 3/4 or the reciprocal of the divisor. Okay, so first one stays, and then the second one's what we flip after the division symbol, and now we can cross cancel because that's one of our multiplication rules, and the 2 and the 4 reduce, and that leaves me a final product now of 2/3 because we were multiplying. But if I would take a calculator and take 1/2 divided by 3/4, it is the same as multiplying by the reciprocal. And so that was just a quick review. So we jump right into division. Now notice that it says assume that all expressions are defined, meaning they're telling us that we don't have to give a domain restriction. If it was not defined, we would need to give a domain restriction. However, I'm going to visit the idea of domain restrictions with you to help lock that idea down. A domain restriction basically is the idea of what can't go into the problem, what cannot be an input. So for example, in this problem, we have x squared minus 1. And so if x is 1, 1 squared is 1, and 1 minus 1 is 0. Negative 1 squared is 1, and 1 minus 1 is 0. So in this piece right here, we would have that domain restriction. So domain restriction is the idea that your denominator cannot equal 0. That's the idea of your domain restriction, something that we've gone over in part 1 of this lesson. Now, I have a fraction divided by a fraction. So I cannot cross cancel. Like, there's nothing really to cross cancel, but even if I had something that would pair up, I cannot do anything with division. So the first thing I'm going to do, I'm not going to worry about reducing anything. Some of you might knock out the x's there, but I'm going to go ahead and leave everything alone just so I don't lose anything or mix anything up. And I'm going to multiply by 9y to the 5th over 16. And the reason I'm not even showing that I could reduce this is because sometimes we get carried away, we reduce this, oh yeah, I can do this, and we forget that I cannot reduce and cross cancel over division. So best thing I think is just to change it to multiplication, and then we can start. I'm going to start with my numbers. 9 goes into 9 once, 4 goes into itself once, and it goes into 16 4 times. We do have those x's that are going to cancel. And I have 1y down here, so that's going to knock that down to 4. So if that's too much for you to look at once, you can piece it out. But in the top, my number is going to be a 1. In the bottom, I was left with a 4. In the top, I was left with x to the 1st and y to the 4th, and my variables canceled out of the denominator. So the 1 is not necessary, so you could have your final answer simply as xy to the 4th all over 4. It's hard sometimes to give a domain restriction when we have 2 variables going on, but this one doesn't have any addition or subtraction. So we're just looking that x cannot be 0 and y cannot be 0. Now there's one extra piece with division with domain restriction. So I said there were 2 new things. One is that we don't divide, we multiply by the reciprocal. So truly not a new thing, but an extra step compared to multiplying rational expressions. The next idea is in the domain restriction, we have to consider the both denominators. So that's not new, but I need you to remember that 16 is part of the denominator. If I had divided by 0, if this was a 0 up here, then that would wipe all of that out. So whenever we do domain restriction with division, we have the denominator, but you have to remember that this whole piece, since I have this divided by something, this whole piece can't be 0, meaning this numerator can also not be 0. So that's the other new piece in division. That's it. Other than that, we're doing the same thing. Now, for some people, they are going to factor and multiply by the reciprocal. So for this example, I'm just going to stick to flipping it and then factoring, but you can skip steps, and I would typically skip steps. But just to make sure that you see what I'm doing, I'm going to go ahead and work it all out. So I'm going to just repeat what I have up there. Okay, it's really important that we make sure that we really do flip the fraction when we change it to multiplication. So again, you could be factoring as you go. Now, that's what I have. The problem with factoring as you go is sometimes we get so wrapped up and we're thinking so hard that we forget to flip it. So always make sure that you take the reciprocal of what you had to be dividing by. So flip your sign, flip your fraction. Okay, now we have a couple things here, and I'm going to go ahead and show this out, but again, I'm going to show you a way to sort of save yourself some work in the next couple examples. First, I'm going to start with GCFs, and the GCF here is x to the third, and I'm left with x squared minus 4. All right, now, if I look at that, that factors again, so x to the third, x plus 2, x minus 2. So that was the first thing I did, was I just took this first piece right here, I took out the GCF, and then I jumped down to here. All right, the next one doesn't have a GCF, so I'm just going to jump right into factoring x minus 2, x plus 1. And I'm just going to carry that down because it's fully factored. All right, we had already flipped the sign and flipped the fraction, so we're set. This top piece factors to x plus 1, x minus 1, and I'm going to bring that down because it's fully factored. And the denominator has a GCF of x to the third. We always want to take those GCFs out because it makes the factoring work. We also want to take them out because we're going to have to do it later, so we might as well make it easier on ourselves. All right, this is a GCF. Now, sometimes these won't factor further, but this one does, and it's going to be x minus 2 and x plus 1. Okay. So if I was trying to save myself some time, I would have just done the GCF right above these and then gone right to here rather than writing it a couple times. But again, I want to make sure you had a clear example of where everything's going. All right, now I can cancel, because it's multiplication, any numerator to any denominator. So don't forget, I can go top to bottom, but I can also cross cancel. So this x plus 1, I might cancel with that one. Someone else might cancel that x plus 1 with that x plus 1. But it's a 1-to-1 ratio, so I can't cancel them all out. It's take one from here, take one from here. This is extra. All right, I can also knock out an x minus 2 with an x minus 2. Again, it's 1-to-1. Maybe you took out these, and that's okay. And then I was looking, I have an x plus 2, not here. I have an x minus 1, not here. I cannot take a negative sign out. If I took a negative out, that'd give me a negative x and a negative 2. So it does not help. They have to be the exact opposite signs. So sometimes you will factor out a negative. This is not a case. There's one more thing that can cancel. Again, we get so wrapped up in these binomials canceling that sometimes we forget that this GCF out front can cancel. So what am I left with? In this problem, the top, I'm left with x plus 2, x minus 1. And the bottom, I'm left with x minus 2, x plus 1. Now, as I'd mentioned in our lesson on multiplying, the textbook that I use will give this answer a lot of times. They won't redistribute or multiply it back out. And so it's nice that you can see your pieces, because if you have one thing factored wrong, it really creates a problem because it looks like a very different answer when it multiplies out. So it's good to check the pieces. So if someone's missing something, their final answer is wrong, I always go back to see what pieces they had and what got canceled out and what should have gotten canceled out. So this could be a final answer. For my classes, I do require that it gets multiplied out. So I'm going to FOIL this. I'm going to get my x squared. I get a negative 1 and a positive 2. So I get a positive x, or positive 1x, and then a minus 2. In the bottom, I'm going to FOIL that out, and I get x squared. I get a a positive 1 and a negative 2, which gives me a negative 1x, and then a minus 2. And so it's really hard to look at this and not be able to cancel these x squareds out or these negative 2's out. But due to the sign being different, due to this being a plus 2 and a minus 2, a minus 1 and a plus 1, these are not like terms. So that is my final answer. And let's talk about a domain restriction, because I think it's important to know. So I'm going to go back to my factored answer for my domain restriction. But you need to remember, this was the original denominator right here, so it cannot be 0. This was the original denominator right here, x squared minus 1, so it can't be 0. And this piece right here cannot be 0, not because it's a denominator in my multiplication problem. It can't be 0 because it was being divided by right here. And so since I was dividing by this polynomial can't be 0. So yes, it's in the numerator, but I was dividing by it. So domain restrictions come from denominator, but this overall would be a denominator, so that can't be 0. So my domain restrictions are going to come from here. X cannot be 2, x cannot be negative 1, x cannot be positive 1, so I'm just going to add to that. X can't be negative 1 and positive 1, so I have that. X cannot be 0, x cannot be 2, I already have it, and x can't be negative 1. So there were several repeats there. Now, later in another section or later in your algebra content, you will discuss what these restrictions do. So every part of the things that cancel out do have a place on your graph, and so we talk about those later. All right, so let's keep moving forward here. We have several examples to practice, and then we get into a couple extra ideas. So we have this. This is a good time to pause the video and try these two examples out. All right, with this first example, I'm not going to do anything until I adjust this. So I'm going to leave it as x squared over 4, and I'm going to multiply by the reciprocal. So we want to make sure that we're doing that well, and then we can go ahead and come in and cross cancel. So the 4 reduces 1 time, and it goes into here 3 times. The y cancels and leaves me 1. 2 of these cancel and leave me 2. So what's left over here is just a 3 in the top, and in the bottom, my 4 canceled out, and I'm left with just a 1. And if you look, then in the top I have a y to the first, and in the bottom I have an x to the second. So final answer, 3y over x to the second. And again, this is acceptable there. All right, now a domain restriction with 2 variables can get a little bit tricky if you have addition and subtraction, but for now I cannot have a 0 in this denominator, and that's fine. The constant's 4, it will never be 0. I can't have a 0 here, so y cannot be 0. But I also can't have 0 in my numerator because I'm dividing by this. So x can't be 0 and y can't be 0. So those are my 2 domain restrictions. Again, they said assume they're defined. I thought it's important to practice that. Okay, in 4b, we have to put a little bit more effort into factoring this first one. There is no GCF, so I'm going to jump right to it. And that would be a 2x and an x, and you're going to have 1 plus and 1 minus here. So you're going to work it out. I'm going to use a plus 1 and a minus 4. Again, it might take you a couple tries, so I'm going to double check myself. 2x squared is 2x squared. There's a negative 8, a positive 1, so there's negative 7, and a negative 4. My denominator has no GCF. It's a difference of squares, factors of negative 9 that add up to 0. So I have an x plus 3 and an x minus 3. All right, now I'm going to multiply by the reciprocal. So notice I'm starting to do some shortcuts here, as in I'm not rewriting all of this, but you can. So this is going to go in the denominator, and that's where I have to be very careful if I'm trying to factor and do the reciprocal at once. Down here would be 2x plus 1 times 2x minus 1. So this would be a difference of squares. All right, now I notice that this piece that's going to move up to the top has a common factor. And so I really want to take that common factor out first. So I'm just going to put it right here to see what I have left, which is going to be a 2x squared minus 7x plus 3. So that helps me not to rewrite this problem as many times as we did the last time. All right, so I keep my common factor of 4. I don't want to lose that. And then I'm going to break this down. And again, I have to think a little bit. So I'm going to have a 2x here. I'm going to need 2 negative signs because I need them to multiply to positive 3 and add up to a negative. And I'm going to put my 1 here and a 3 here. So that was a lot easier to factor rather than trying to do trial and error with an 8 and a 12 where there's more than one set of factors. So now that I have this all set, I'm going to double check it. I've got my 2x squared. I've got a negative 6 and a negative 1, so there's my negative 7. Negative times the negative is a positive. It's really important that you double check your factoring. Simply having the wrong sign or a wrong number is going to change everything how it cancels. Sometimes it will work out and you think you're canceling correctly and you'll find out that was the wrong piece. So we can cancel this 2x plus 1 by cross-canceling with the other 2x plus 1. I can actually cancel the 2x minus 1 with that. So any top to any bottom or cross-canceling since we have multiplication. I can also cancel out an x minus 3 with an x minus 3. And I think that's all I have. I also want to double check. I had a 4 out here. I had that constant, that GCF. Nowhere else do I have something that can cancel. So what I have left in my numerator is a 4 and an x minus 4. So x minus 4 and 4. And I have in the denominator an x plus 3. So again, those are the pieces that I have left. I'm going to go ahead and redistribute and multiply out. So I have a 4x minus 16 over x plus 3. And if we're talking about a domain restriction for this problem, we are going to talk about what x cannot equal. And we're looking at our denominators before we canceled. So in this piece, x cannot be a negative 3 or a positive 3. So x cannot be a plus or minus 3. In the original denominator, the 4 will always be a 4, but x cannot be a positive 1/2. Again, this is something that you might take off to the side and say, hey, 2x minus 1 cannot equal 0, and then you add the 1 over and divide by 2. And that is where I get my 1/2 from. All right, x cannot be 3, which I already have, so I don't need to repeat it. See if we can get this a little better focused. There. All right, and then we have that piece done, and then this was in our original numerator, but we were dividing by that. So the 4x squared minus 1 also cannot be 0, and so we have that 1/2 here. We also have a negative 1/2 from here. So a plus or minus 1/2. And there you have it. Okay, so that's the lesson on dividing rational expressions. Okay, so 2 big changes. You don't do anything with division. You multiply by the reciprocal. So first thing we did was we talked about multiplying by the reciprocal. We factor like always. We cross cancel. We reduce top to bottom. And then the other thing that we do is we talk about the domain restriction coming from the denominators, just as before, but also from this piece in the numerator as it is dividing by this whole fraction. Okay, so something a little different here. We're introducing the idea of solving rational equations, but notice these are simple rational equations. So one option is to put this over 1 and just to cross multiply and solve it, but sometimes that makes it more of a mess. So what we're going to do is we're going to go ahead and we're going to factor. We're going to factor the x plus 3, x minus 3, just as we would if it wasn't set equal to anything. Okay, and that's going to be over x plus 3. It's still equal to 7, but we're focusing on cleaning up the left-hand side, and we're going to cancel out the x plus 3's. So what I'm left with is x minus 3 equals 7, which is a pretty simple equation to solve. And so I add 3 to both sides, and I get x equals 10. Now, I do have to be very careful because there are domain restrictions that are important. So my domain restriction with this problem comes from my original denominator before it got canceled, x plus 3. And so I'm just going to squeeze this in here for the idea. This cannot be 0, so x cannot be negative 3. And again, it's really important to define it as x cannot equal. The domain restriction is telling you what x can't be, so you want to define your variable. So x can be 10, and it is not affected by our domain restriction, so we're good. So let's try another one. Still a simple rational equation, but I'm not going to worry about the equal to 5. I am going to worry about cleaning up anything I can. So this is going to factor in the top as x plus 4 and x minus 1. And in the bottom we have x minus 1. And I want to remind you, these problems are set up to create this working this way. And the x minus 1's cancel, and I'm left with x plus 4 is equal to 5. So subtract 4, and I get x equals 1. Now, if I walk away from this and I think, okay, I'm done, no big deal, doesn't ask anywhere for a domain restriction, I have just gotten this wrong. Because if I take 1 and I plug it back into here, that's okay. But if I put 1 into the denominator, 1 minus 1 is 0, and that's not okay. So I do need to check that domain restriction because it will throw out some of my answers. And because x minus 1 is 0, we add 1, the domain restriction states that x cannot equal 1. So I actually have to throw that answer out